The fuel system is designed to provide fuel to both engines and the APU. The fuel system consists of three systems. The storage system, which includes vented, integral fuel tanks in the aircraft wings. The distribution system, which permits operations like engine feeding, APU feeding, tank refueling and defueling. And finally, the fuel indicating system, which provides indications and failure information to the crew and maintenance personnel. The aircraft has two structurally integral wing tanks. Each wing contains a surge bay to collect fuel during wing down or uncoordinated maneuvers, a main tank, and a collector bay which ensures continuous fuel feed to the engine throughout the whole flight envelope. The arrangement of the tanks permits the fuel to flow from the outer tank area to the wing route and into the collector bay. Each tank contains float valves and flapper check valves that prevent fuel from escaping from the collector bay and prevents fuel from entering the surge bay. The tank vent system is designed to keep the pressure differential between the tank and ambient within structural limits under all operating conditions, and to prevent fuel spillage during flight maneuvers and hard braking. Each fuel tank is vented through three independent lines into a surge bay located in the outboard section of the wing. Due to gravity, water inside each fuel tank will collect at three locations in each wing. The three drain valves in each wing, located at the lowest points of the surge bay, the main tank, and the collector bay, which can be opened to drain the accumulated water.
Each fuel tank is formed by the structure of the wing itself. This is known as an integral wet wing tank. The fuel tanks are formed by the front and rear wing spars and the upper and lower wing skins. The wet wing tanks are prevented from leaking by sealing all the ribs, stringers, joints, spars, and fasteners with sealing compound. Access panels on the upper wing skins give access to the surge bays, main tanks, and collector bays. Each fuel tank is vented to its related surge bay through an inboard vent line. The surge bay itself is vented to the outside through two NACA vents located on the underside of the wing. Each surge bay also has two vent float valves. The valves are closed by rising fuel to prevent the surge bay from filling in certain flight attitudes. The NACA vent air inlets direct ram air during flight into the surge bay, then through the vent pipe and vent float valve to the tank.
Fuel is carried in two integral wing tanks with a total capacity of 5,318 kilograms, 11,724 pounds. During normal operation, each wing tank supplies fuel to one engine through a collector bay, located at the inboard end of each tank. The APU is supplied with fuel from the number 1 fuel tank. The engines are fed by means of primary ejector pumps, which are driven by high-pressure motive fuel flow, supplied by the dedicated engine fuel pumps. The backup electrical pumps in each collector bay ensure engine feed in the event of a primary ejector pump failure, and also provide a source of pressurized fuel supply to the engines for ground and in-flight start. Pressure refueling and defueling can be accomplished through a single-point refuel-defuel adapter located in the right nacelle and is controlled from an adjacent refuel-defuel control panel. As an alternative to pressure refueling, each tank can be filled from an overwing filler point. Each tank has its own capacitance-type fuel quantity indicating system, which provides an input to control pressure refueling-defueling levels in addition to its primary function. Fuel low-level warnings are also provided for each main tank. Drain valves, located at the low points in each tank, are provided to permit checks for water accumulation and to drain residual fuel from the tanks when required. A fuel tank temperature indication system is installed in the left tank. Engine feed from each tank to its associated engine consists of an engine feed pumping system housed in the collector bay and a fuel emergency shutoff valve. The pumping system consists of a boost ejector pump as the primary delivery matter and an auxiliary pump with 2 check valves. The auxiliary pump is also used for fuel transfer and defueling. The boost ejector pump is a Venturi with no moving parts, which derives its motive power from the engine-driven fuel pump. The auxiliary pump in each tank is electrically motor-driven and mounted on the wing lower skin inside the collector bay section of the tank. Each pump is controlled from an auxiliary pump switch on the fuel control transfer panel in the flight compartment, marked Tank 1 or Tank 2 auxiliary pump. A Tank 1 or Tank 2 auxiliary pump switch indicator on the MFD fuel page shows the position of the switch light. When the pump is supplying sufficient boost pressure, the Tank 1 or Tank 2 auxiliary pump light on the fuel page and the related on switch light segment turns green. During normal operation, fuel is delivered under pressure to each engine by the boost ejector pump of the engine feed pumping system. Check valves located in the delivery lines from the boost ejector pump and the auxiliary pump prevent reverse flow through the ejector or pump. The fuel emergency shutoff valves, located on the rear spar outboard of each nacelle, are used to close the engine feed line in the event of an engine fire and can also be used for closing off the line during maintenance. Valve position is indicated by a green fuel valve open light and a white fuel valve closed light for each valve. Loss of fuel pressure due to failure of ejector delivery closes the fuel low pressure switch in the engine feed line. This signals a corresponding engine fuel pressure caution light to illuminate. To compensate the pressure loss, the corresponding auxiliary pump should be selected to on. When the pump is supplying sufficient boost pressure, the corresponding auxiliary pump light on the fuel page and the related on switch light segment turns green. The engine fuel pressure caution light will remain on until pressure in the fuel delivery line increases to open the fuel low pressure switch.
Fuel for APU operation is supplied by gravity feed from the number 1 fuel tank through piping in the dorsal fairing to the APU fuel enclosure. Fuel supply is controlled by the APU PWR switch light located in the flight compartment on the APU control panel. The fuel supply system is interconnected with the APU start-stop circuits. When the APU speed reaches 3%, the fuel flows to the unit. The fuel system is de-energized to shut down the APU. The system is electrically powered by 28-volt DC from the right main bus through a 5-ampere APU fuel circuit breaker. The APU fuel supply system has a fuel shutoff valve which is controlled by the APU power switch light. The valve position is shown by a green fuel valve open light and a white fuel valve closed light on the APU fire protection panel on the overhead console. The APU shutoff valve closes and stops the fuel flow to the APU under the following conditions. The APU power switch light is selected off. Fire is sensed in the APU tail cone area. The APU fire extinguisher switch, EXTG, on the fire protection panel is selected on. And the weight on wheels switch is open, aircraft off ground.
The fuel tanks are normally fueled to provide an equal quantity in each tank, and since each tank feeds its own engine, there is usually no requirement for fuel system management during flight. Shutdown of an engine could require fuel to be transferred in order to prevent a large imbalance of fuel between the two tanks. If the fuel quantity computer detects a fuel imbalance of more than 272 kilograms, 600 pounds, a balance message flashes just above the fuel legend of the engine display and will flash until the imbalance is corrected. An imbalance condition will also be shown on the fuel page by the analog quantity dials changing to solid yellow. A transfer switch on the fuel control transfer panel controls the fuel transfer system, while the fuel transfer operation is monitored via the MFD fuel page. When the transfer switch is selected, the auxiliary pump in the donor tank operates automatically to pump fuel to the receiver tank. A signal from the operating pump causes the related on switch light segment to turn green. Electrically operated fuel transfer shutoff valves open for fuel transfer and close when the transfer is stopped. Once selected, fuel transfer will continue until deselected by the flight crew or until a high-level sensor in the wing tank detects an overfill condition. Note: fuel cannot be transferred if the fueling on caution light is on. This caution light comes on if the refuel-defuel access door is open. The refuel-defuel system provides for simultaneous or independent pressure, refueling or defueling of the two integral wing tanks. Located at the rear of the number 2 engine nacelle, a single refuel-defuel adapter and the refuel-defuel control panel are accessible via the refuel-defuel door. When DC electrical power is supplied to the aircraft, the fueling on caution light will come on when the refuel-defuel door is opened. Refueling can be accomplished either automatically, pre-select refuel, or manually. Gravity refueling can be done through the wing-mounted gravity refuel adapter located on the top surface of the wing. When the rotary selector is set to the pre-select refuel or refuel position, the master valve closed light goes out to show that the refuel-defuel shutoff valve is open. Note: the refuel-defuel shutoff valve will close when the refuel-defuel door is closed, regardless of the rotary selector position. During pressure refueling, fuel pressure opens a vent dump valve in each tank to vent the tanks through the surge bay. For automatic refueling, the desired quantity must be selected by using the increase-decrease toggle switch. After 4 seconds, you release the increase-decrease switch, and the valve control switches are set to the open position. The refuel flow starts. Proper operation of the refuel shutoff valves can be checked by momentarily holding the valve control switch for each tank in the pre-check position. The related refuel shutoff light comes on and when the selected quantity is reached, the level control shutoff valve automatically stops the fuel flow to the related tank. During manual refueling, the desired quantity in each tank is controlled by the pre-check open/close switches, while the refuel/defuel indicators will display the individual tank quantities. With the rotary selector turned to the refuel position, refueling continues until the pre-check open/close switches are selected to the close position, the selector switch is turned to the off position, or until the high-level sensors sense a full tank condition. For defueling, the rotary selector is turned to the pre-select defuel position. The fuel quantity computer closes the refuel/defuel valves to automatically stop defueling at the preset quantity. When the rotary selector is turned to the defuel position, defueling continues until the selector switch is turned to the off position. The fuel quantity indicating system is capacitance type, operating from the aircraft 28 volts DC power supply. Here are the main functions of the system. It measures the mass of fuel in each tank and displays the contents on the engine display. The MFD system fuel page, and on the refuel/defuel panel. One magnetic dipstick installed in each tank provides an alternate fuel measuring device. The fuel quantity indicating system for each fuel tank is identical. Each consists of 9 probes, which are mounted inside each fuel tank. The probes in each fuel tank are electrically connected in parallel to feed the fuel quantity computer to calculate the aircraft fuel quantity. Low fuel level is sensed by a float switch in each collector bay and indicated by a caution light on the caution and warning panel. Fuel tank temperature is measured by a temperature sensor in the left collector bay and is displayed on the fuel system page. The fuel indicating system in the flight compartment is displayed on the engine display and on the fuel page of the MFD. On the engine display, the fuel quantity in pounds or in kilograms and temperature in degrees Celsius are shown in white digits. White dashes replace the display digits if the data is not valid. The fuel temperature display indicates the temperature of the fuel with a plus or minus sign after it has passed through the fuel oil heat exchanger and is normally displayed in white digits. The digits will turn yellow if the temperature is below 0 degrees Celsius and will turn red if the temperature is above 71 degrees Celsius. If a fuel imbalance condition is detected, a yellow balance advisory message is shown and flashes continuously until a pilot action rectifies the imbalance. Engine fuel consumption is indicated as fuel flow in pound per hour or in kilograms per hours, in white digits, and is replaced by white dashes when the data is not valid. The fuel page of the MFD shows the fuel quantity in each tank on 2 simulated analog dials and the total fuel quantity in digital form, and can be shown in kilograms or pounds. The analog dials are divided into pounds multiplied by 1,000 or kilograms multiplied by 1,000 segment. The pointer segment is normally white, but will turn yellow during an imbalance condition. When the parameter is not valid, the pointer is removed. The fuel tank temperature indicates that temperature in left collector bay with a plus or minus sign. The indicator range is from -99 to +99 in 1 degree increments. Whenever the data is not valid, the digits are replaced by white dashes. The auxiliary fuel pump switch annunciator in the off position is shown in white text surrounded by a white box. When selected to on, the segment is shown in reverse video with black text on a green background. White dashes replace the text without a box when no data is available. The tank auxiliary pump pressure status indicator circle segment is white outlined with black fill when there is a low or no pressure. The circle segment is white outlined with a green fill when the pressure is normal. The fuel shutoff valve annunciator indicates the shutoff valve state in response to a crew transfer request. When closed, the valve close segment is displayed in white in upper white outline rectangle. When selected to open, the open segment in reverse video, black text on green in lower rectangle, indicates that the fuel transfer valve is open. When the valve is neither fully closed nor fully open, typical case during valve transition, nothing is displayed. 3 white dashes are displayed instead of the closed and open indication when no data is available. The fuel transfer switch indication indicates the position of the fuel transfer switch on the fuel control panel. The transfer switch segment and the 2 tank 1 and 2 tank 2 segments are displayed in white. The triangle segment, white in white outline rectangle, is pointing toward the left to indicate that a transfer is active from right to left. When pointing toward the right indicates that a transfer is active from left to right.